Hey guys, let's do some word problems in this video. The question states that there are three strings of different lengths. So let's say there are three strings of different lengths and the lengths are given, and these are to be cut into equal lengths. So these are to be cut into equal lengths. And it is asking that if these strings are cut into equal lengths, what is the greatest possible length of each piece? If you consider the length of each piece as, let's say for example, 10 centimeter, you are going to get 24 pieces of 10 centimeter each if you cut this 240 centimeter long string. But if you cut this 318 centimeter long string into pieces of 10 centimeter each, you are not going to get pieces of equal length. Same is the case with 426 centimeter long string. The reason being that 240 is divisible by 10, but 318 and 426 are not divisible by 10. So you ought to take a common factor of these three numbers. And if you want the greatest possible length for this string, this number should be the greatest common divisor, that is the highest common factor of these three numbers. So there you go, you have the concept ready. You just have to find out the highest common factor of these three numbers. So HCF of 240, 318 and 426. Now you all know how to calculate the highest common factor of three numbers. So to save time, I have already calculated the HCF of these three numbers, and this comes out to be 6. So our correct option is option B, 6 centimeters. Okay, moving on to question number 2. It says that there is a person Raju who goes to the park every 8 days, and he has a friend Salim who goes to the park every 6 days. They meet each other one day, and the question asks you how many days later from that day will they meet again. So let's talk about Raju first. So we have Raju, and he goes to the park every 8 days, it is given. So let's say today is the point of reference, and after 8 days he'll come again. Then he'll come after 16 days if we take today as the point of reference. Then after 24 days, basically this is multiples of 8. So 8 times 3 is 24, 8 times 4 is 32, then 40, and so on. Similar is the case with Salim. Suppose today he comes, then he'll come after 6 days, thereafter 12, 18, and so on. So basically we have multiples of 8 and multiples of 6. What is the common multiple which is the lowest? The least common multiple of 8 and 6. And the LCM of 8 and 6 is 24. So our answer is 24. Question number 3. It says that there are 294 blue balls, 252 pink balls and 210 yellow balls, which are distributed equally among some students with none left over. That means all of the balls are distributed equally to the students. Now what is the biggest possible number of students here? Now if you have to distribute equally, then you have to divide these three numbers with a common number. And that common number which is asked in this question should be the biggest possible number. And if that should be the biggest possible number, then it is bound to be the highest common factor of these three numbers. So HCF of 294, 252 and 210 is equal to, we have to find. Now let's find out by using prime factorization. And I have created this factorization tree for you. So the prime factors of 294 are 2 into 3 into 7 square. The prime factors of 252 are 2 square into 3 square into 7, and the prime factors of 210 are 2 into 3 into 5 into 7. Now the highest common factor by the method of prime factorization is equal to the product of common prime factors with lowest power. So the common prime factors are 2, then we have 3, and we have 7. So the lowest power of 2 is 1, so we have 2 into the lowest power of 3 is 1, so we have 3 raised to 1, and the lowest power of 7 is again 1, so we have 7 there. So 2 into 3 into 7 comes out as 42. So our correct answer is 42. Now let's move on to question number 4. Two lighthouses flash their lights every 20 seconds and 30 seconds. Given that they flash together at 7 p.m., when will they next flash together? Let's say that there are two flashlights, A and B, and let's first write the timeline of A and the timeline of B. So the timeline of A, it flashes every 20 seconds. So there is first it will flash at 20, then it will flash at 40 seconds, then it will flash at 60, and so on. And in case of B, it will be 30's multiples, so it is 30, 60, and so on. Now what will be the time when they will flash together? Again, it is the problem of least common multiple. We have to find out the common multiples of A and B and the least amongst them. So the LCM of 20 and 30 is LCM of 20 and 30 is 2 into 2 into 5 into 3, and that comes out as 60. Now 60 seconds is 1 minute, and it is given in the question that they flashed together, these A and B lighthouses flashed together at 7 p.m. So they flash together at 7 p.m. and they will flash together at 1 minute later, because they flash every 60 seconds together. So they will flash 1 minute later. So our answer is 7.01 p.m. because they flash together at 7 p.m. they will flash 1 minute later, that is 7.1 p.m. Okay, the final question. A man has a garden measuring 84 meters by 56 meters. He wants to divide them equally into the minimum number of square plots. What should be the length of each square plot? Okay, this man has a garden measuring 84 by 56 meters. So let's say this is his garden. It has 84 meters as the length and 56 meters as the width. He has to divide his garden into plots measuring equal length. These are square plots. So he wants to divide them equally into the minimum number of square plots. He wants to divide his garden in such a way that the number of square plots should be minimum, which means that the length of the square plot should be maximum. Now if the length should be maximum, it means that the length should divide the length of his garden and the width of his garden exactly. That means that the length of each square plot should be the highest common factor of these two numbers, 84 and 56. So we have HCF of 84 and 56. Let's divide 84 by 56. We have 56 times 1 is 56, and we get the remainder as 28. Then again we will divide 56 by 28. 28 times 2 is 56, and the remainder is 0. So 28 is the highest common factor of 84 and 56. Hence our answer is 28 meters, because it is the maximum length of the square plot that can be reached if the garden is of 84 by 56 meters.